Yeah, so we're on page 61 of your student journal. So you could tear all of chapter 3 out, but that would be helpful to you. But for sure, have this one next to you as we're going through our lesson today. Terms we're going to talk about: relation, function, domain, range, independent variable, and dependent variable. All right? So good place to take notes. Just keep it next to you. All right. So let's try some of these and let's talk about what they mean. Chapter 3 is an amazingly big chapter. Okay, so let's study some of this stuff. A lot of it's going to be somewhat of a review, but term relation and the term function. A relation is any ordered pair. Okay, so like we were talking about in one of my other classes today, thought Mac did a good job of pointing out. Like if it's a pair, it's called a relationship. Like if you see two people cruising down the road holding hands, you assume they're in a relationship. Maybe. Okay? That's a relation. Two things together. That's a relation. So these are all relations. A special relation, when you put multiple relations together, multiple sets together, a special relation would be called a function. Okay? A function is when each input value has only one output value. Okay, so there are a bunch of terms there. What's an input? Yeah.
Input is actually what I was going to ask. Can one output have more than one input?
Yeah, it can. Yeah, let's talk about that here in a minute. Okay, the word input means X. The word output means Y. All right, so some pieces there. So a function is when each input has only one output. Okay, so if I'm looking at this, if I'm trying to figure out if a relation is a function, I'm just going to see if my x's repeat. Do the x's repeat ever? No. -2, -1, 0, 1, 2, they don't repeat here. Therefore, this is automatically a function. You don't have to worry about doing anything else. Your explanation, each input has only one output. What's that? This isn't on a page, right? These are just notes. You guys. So these aren't in your student journal. So this is what you're doing on your note page. Yeah. So look at your inputs. Well, let's do this one, see if it makes more sense. On this one, do any of your inputs repeat? Yeah. Which one repeats? 4 repeats. Okay. So 4 here is saying the output for this input of 4 is 0. And then they input 4 here and they get 3. Therefore, the same output, or same input, has different outputs. This is not a function. This is just a relation. Okay? So not a function. Function. Ooh, that could be bad. Function. Because 4 gives an output of both 0 and 3. Can I show you on a graph here in a minute? Okay. All right, why don't you try C and D? Work together. Is it a function or is it not a function? Okay, letter C, what do we think? Input or function or not a function? Who says function? Who says not a function? If it's not a function, what number? 0. Our hero is our problem there. It has an output of 5 and an output of 6. Okay? How about letter D? So this one's no. This one, function?
No. Yes. No.
Does each input go to one output, only one output? Yeah, -1 goes to 4, 3 goes to 15, 11 goes to 15. It's okay if the same input or if different inputs go to the same output. That's okay. It's just the same input can't go to 2 different outputs. So it's okay for both of these inputs to go to that output. But this 3 wouldn't be able to go to 4 and a 15. That would be bad. Okay? So really when you're talking about a function graphically, so Sarah's question about why does it matter? Well, when you're putting these into a graph, so if I focus in on C and D, and I'm just going to graph these coordinates real quick. Which that didn't focus pretty darn. It's a little better. Okay, we go -2 and 3 right there. Okay, those are all of our points for letter C. You'll notice that in this graph, I don't even need to connect the points, but if I were to take my pen and just kind of lay it on the graph and then start moving across the page, my pen, or if I were to look at a vertical line, think of it this way, let's use a highlighter there. This vertical line right here hits just that one point. This vertical line hits just that one point. This vertical line right here hits how many points? 2. This graph does not pass a vertical line test. Okay? A vertical line test that says that if at any point a vertical line can be drawn on my grid, or it's easier if you can take a pencil and just scroll it across the page, but if any point a vertical line drawn on my grid hits more than one point on my graph, then it's not a function. This does not pass a vertical line test. Okay? If I were to do the same thing for part D here and plot these points, this is an ordered pair -1, 4. It's a little harder to see, but that's all that is. This represents 3, 15. And this one represents 11, 15. Okay? So I'm going to have to change up my scale here. I'm going to call this 20 for my y-axis. But I got -1 and 4. So that's right there. I got 3 and 15. So that would be, 2, 4, 6, 8, 10, 12, 14, 15. Okay. Oh, you don't have to. Oh, I guess I'd have to do it for 11. Yeah, is that what you're talking about? That's okay. I'm going to put 11 out here. Okay. And 11 and 15 would be right here. That's a good point. I probably should have, Quentin. Okay. Does this pass a vertical line test? Yeah. Draw a line there, hits that point. Draw a line there, hits that point. Draw a line here, and it hits just that point. Right? What's that? We're not worried about a horizontal line test. Yeah. Not, unless you're dealing with the inverse function. Okay, so this passes a vertical line test. Therefore, this is a function. All right. Yeah.
This might be a little off topic, but I noticed that the line can flatten after arcing. So does that mean you can get a line? Does that mean you can get a graph that'll be a circle?
You can, yeah. All right. Quickly, just yes or no and why or why not. Tell your neighbor. 1 through 4.
Yes. Yeah, but 5.
Okay, number 1, who says yes? Who says no? This is no. What's the problem? What number?
5.
Our input of 5 goes to 2 different outputs. Okay? Number 2, yes or no? Yes, this is a function because -4, -1, 2, 5, they don't even repeat, so automatically a function. So we're good there. How about this one? 2, 4, 6, yes, doesn't repeat. Okay, how about this one? No, 1/2 goes to all of these. Dude, that's ridiculous, man. Okay, this is not. So we frown on this one, we frown on this one. Yes? Because the inputs don't repeat. Okay, so really the first step is when you're figuring out the function, just see if your input repeats. Okay? Question? Is it on topic?
No.
Okay, then we're not doing it. Okay? So, vertical line test. There's a summary of vertical line tests. Okay, you could ask me in a while. Okay? All right. Is this in your student journal? Vertical line test? That's ridiculous, man. That vertical line test is awesome because when you have graphs, Oh, it's on the next page? Shoot, do they have the cool function machine on there too?
Yes.
Yeah, all right. Well, using the vertical line test, we kind of use the highlighter to talk about it. You should be able to look at those and tell if it is a function or not a function. So quickly, neighbor, yes, no, or why or why not?
Yes, yes, no, no. The circle is only no.
Okay, raise your hand if you think this is a function. Yes, it is. It passes the vertical line test. We move the vertical line across the page. It only hits one point at a time. If the line's thin enough, my pen's not thin enough. Yeah, man. How about this one? Yes. How about this one?
No.
No. Why?
It's multiple. More than two.
It's more than 1 point. Okay? It's multiple points. Okay?
Some places it's more than two.
Yeah. Okay, so your explanation on these, you could just say, hey, it passes the vertical line test. Passes the vertical line test. Doesn't pass the vertical line test. Does this one? Yes. All right. All right, right now rate yourself 1 to 5. 5, you get it. 1, you're struggling. About to get a little more complex. Okay. Here we go. This is a function machine. Now, function machines, I don't know. I never got into the function machine thing. There's some teachers that absolutely, they swear by the function machine. They're like, dude, you put something in, you do some junk to it, and you kick something out. Okay. I don't know. It's like, who knows? But I'll explain what a function machine does here in a minute. Let's talk about domain and range. Domain is the set of all input values. What is an input value again? Your x. So your domain is actually your x, right, x? Yep. Okay. Your range is your y. Okay. Domain starts with a D. A range starts with an R. And D comes before R in the alphabet, just like X comes before Y in the alphabet. These are just other names. Okay? How many have middle names? How many have nicknames from friends? Hopefully appropriate nicknames. Okay? How many have nicknames your family members give you? Like maybe your dad or your grandma. Okay? Or your mom. They may give you weird little nicknames. All right? So these are just nicknames for X and Y, if you think of it that way. We call X domain and range Y because we call it X domain and range Y. We have other names for them. So you just need to know the other names. No. You can say domain and range, though. You're learning the language of math. The domain and range will represent different values on a graph. Okay? So let's talk about what domain and range do. Find the domain and range of all of the function represented by the graph. Work with your partner. You get about a minute to try your best on it. So Sarah's question, why can't we just call them X and Y? Well, there are multiple X and Y's. X's and Y's. X's and Y's. Okay? Yeah. So this has a coordinate of what?
-3 and positive.
How about -3 and -2? Okay? What's this one? And here? And here? Okay. So those are my X and Y values on that graph. So if I'm saying my domain is X, so my domain is -3, -1. I'm listing all my X's. 1 and 3. That is my domain. It's all of those. It's only those, though, right? It doesn't include any other points there. What is my range?
It'd be your
-2. So, Jason, you said -2 to 4, right? But it can't be the things in between. Okay. How many are with me so far? Any questions on it? Sarah? Okay. All right. Domain and range. Letter B. What's this point?
-2, -2.
-1.
-2, -2. Oh, -1. Okay.
Oh, yeah.
Okay, this one? Okay, now. Yeah?
How is that -2, -1?
That's negative.
-1, -2. Right? So you go over 2 and down 1. Yep. All right. So when I'm dealing with my domain here, Mercedes, you know what to do? Oh. I thought your hand was up. I didn't see it. What do you got, Isabella? -2 and 3. You just put those 2 points? Yeah, if we just put this point and that point for domain, what about all the things in between? So I'm gonna go ahead and write -2 and 3. I like that. Yep. Well, it represents all values from, like on the x-axis. When I say -2 to 3, I'm representing all these values right here. But I have to write an inequality to state that. So how could I write an inequality to say I want anything this way and anything this way on the x-axis? Good. I want all values that are greater than -2. Can they be equal to -2? Yeah. And I want all values that are less than or equal to 3. Or if I write that in this form, I put the -2 first, 3 in there. We put it in numeric order, and we put the inequality symbols. This one points to the
Left.
and this one should point to the. That is my domain. It's saying x has to be greater than or equal to -2, but less than or equal to 3. Just like we did last chapter. Okay? You're not graphing it. You're just listing where the graph exists. So you're saying this graph exists between these points on x. And for your range, you're going to say the same thing, but on the y. So you're going to kind of go the same route. Y, it starts at 2. Or you could say it starts at -1 and goes up to 2. It exists right there. It exists between those points. So I want everyone to write the range of that graph. Use an inequality. That's a good call. Yeah, when you're dealing with these, greater than is going upward and less than is going down. Okay? So here, up here, I'm saying y is less than or equal to 2. But I'm saying y is greater than or equal to -1. So if I put those two things together in an and statement, I put numerically -1, 2. I put the y. This one opens, oops, like that. And there. How many got it? Okay, I'm going to be walking around. I want you to do these 2 questions. You work with your groupies. It's fine. Try those 2. And then if you have questions for me, stop me as I'm coming by. All right, guys, just so we know that there's a dot right there. Maybe a little easier to see. Guys, so there are 2 different ways we see domain and range. One is using what's called discrete data. Okay? Here our domain is discrete. Here it's continuous. Discrete means there are just points. Continuous means you have a curve or a line or something connecting them. Okay? So when you have discrete data like this, you just list it by the coordinates. So we know x here is at -2. x here is at -1, x here is at 0, x here is at 1, x here is at 2. So we just list -2, -1, 0, 1, and 2. That's the discrete data. What's that? Continuous. Range. In this one, we're dealing with y. And with discrete data, you just put the other coordinates. So you got 4, 2, 0, 2, and 4. Now, do I have to keep listing those ones that repeat? Like, right now, if I put 4, 2, and 0, do I have to list 2 and 4 again? No, they're already there. If you did, that's okay. Our domain and range. Okay, since these repeat, you don't have to relist them. That make sense? That is discrete. Continuous, when you're dealing with continuous data, your domain is where you have your inequalities. So you say, well, it starts, this one starts at 1 on the x-axis, and it goes to 5 on the x-axis. So my graph exists between this point and that point right there, using the x as a measuring stick. Really, that's what you're doing with x-axis. It's like having 2 rulers you set down on your table. One's x, one's y. My measuring stick says, well, x goes from 1 to 5. It's bigger than 1, or equal to 1, because of the open dot, and it's less than or equal to 5. My range switches it up. And we say, well, if I'm dealing with my y-axis, I'm going from this point to that point. I'm using this measuring stick. Okay? I start at 0, so we go numerical. I go to 4. And then in between, it's getting bigger than 0, so y is greater than or equal to 0, because it hits here. And it actually has an open circle on those, so less than or equal to 4. What's that? Like in these, if there was like an open circle right here, just like we did last chapter, if this was it wasn't filled in, it was just an open circle, then it would be, no, it wouldn't have the equal to piece. But since it's filled in, you have to have the equal to part. All right, who thinks you get it now? Good? Yay? Nay? When I'm coming around, if you're like, I still don't get it, make sure you ask me, please. Questions? All right, last piece. I think we have hit on all these terms except for 2. Independent and dependent. All right, so let's talk about this. Here is number 11. This is, once again, not in your notebook, but it's something we're going to go through, take notes on. So, looking at this guy, the function a equals -4b plus 14 represents the number of avocados you have left after making b batches of guacamole. Now, first, how many of you eat avocados? How many of you eat guacamole? Okay, so some of you, I'm starting to like guacamole. I used to hate it. So, okay, if you have your earbuds in, please take them out. I see 3 right now. Okay. Please get to the point. You guys are now in 9th grade, and if you're not in 9th grade, you're in 9th grade class. So you have to be able to look at a story problem and go, oh, I can try that, versus going, oh my gosh, there are words, and be done. Like that. A lot of students, like up to this point, they look. There's word. Okay, I don't know how to do that. McCoy, I don't know how to do that. Well, what part? Well, I don't understand. Have you read it? No, but there are like words. Okay. So, identify the independent and dependent variable. I want everyone to tell your neighbor the alphabet, please. Tell them, like, read through from A through Z. In order. I'm serious. Hey, now I realize some of you are too cool to say the alphabet to your neighbors. Either that or you just don't know it. That's okay. I understand. So, If I go A, B, C, D, E, F, G, H, I, J, K, L, M, N, P, Q, R, S, T, U, V, W, X, Y, Z. Do what I did. Look how fast. Go. A, B, C, D, E, F, G, H, I, J, K, L, M, N, P, Q, R, S, T, U, V, W. X is next, right? And in order to get to the thing after X, what's after X? Y. In order to get to Y, you must say... In order to get to Y, you must say... Therefore... Unbelievable. Therefore, Y is dependent upon X. No, we're not going to go there. Independent is X, dependent is Y. Y depends upon X. That's a good way to remember it. In the alphabet, if you cannot, like, once again, these are new names for X and Y. Domain means X, independent means X. Range means Y, dependent means Y. They are the same thing. They mean the same thing. If you cannot remember, just keep in mind the alphabet. You can't get to Y unless you say X. I don't want it unless it's a serious question. Yes? Then you don't have to do it. Yeah, don't do it. Come up with your way. That will work. Okay? All right. Identify the independent and dependent variables. So tell your neighbor what, I don't want this answer. This is not my answer, X and Y. Hey, McCoy, the dependent or the independent is X, the dependent is Y. There's no X and Y. Well, McCoy, which one depends on what? In this equation, where would the Y usually go?
Next to the 4.
Are you in place of the... Are you kidding?
Yeah, if you're dealing with a linear equation, it'd be Y equals MX plus B. Hey, man, give him a break. Okay?
Very sorry.
Y equals MX plus B. Y would replace A. If you're thinking through it, start thinking about what depends on what. The number of avocados you have left after making B batches of guacamole. Well, if I make one batch, I'm using avocados. Okay? So the number of batches I make, that is my independent. My dependent is how many avocados I have left. If I make one batch, I'm going to have more left than if I make 5 batches. If I make 3 batches, I'm going to have more avocados left than if I make 20 batches. So in this case, the number of batches is my... Oops, I should have used another color there. My bad. Number of batches is my independent. And if you want, you could put the B. And the dependent would be number of avocados. So those of you who are like, why is he saying hashtag avocados? And I'm not going to tag it anywhere. All right, like that actually means number up. If you didn't know that, I don't know. You guys still use the pound sign for number? That's like what we used to use it for. Now you guys have changed it to the silly world of hashtag. I see number all the time. Number mariners. Like hashtag mariners. Yeah. All right. If the domain is 0, 1, 2, what's the range? Tell your neighbor how you're going to do that. If your domain is 0, 1, 2, 3, what's your range? How many have made a T-chart before? So like you made a T-chart where you have X's and Y's. We're going to make this type of chart. What type of chart is that?
Both are T's.
Good. Some people call it a double T. Some people call it an H chart. I just call it a chart. Okay, we're going to make this X and we're going to make this Y. Okay, and you know X stands for what? Domain. And Y is? Range. So they're saying, hey, when your domain is 0, 1, 2, and 3, what is your range? Or if my input is 0, 1, 2, 3, what is my range? Okay? It's not the same thing because they've given you a rule up here. This is your rule. And they're not calling X, they're calling XB in that one, right? They're changing the context of the problem. So our domain here stands for B. Okay? If we think of it that way, you may actually want to say that's actually B in this problem. And Y is actually what letter? It's A. Okay? So for those of you who are like, well, that's confusing. Why can't I just call it A and B? You can. You could call that B, and you can call that A. You don't have to put the X and the Y.
X and Y make more sense.
Yeah, so then you just take this piece right here. Here's your rule. You're going to go ahead and put negative 4B plus 14. And then we're going to substitute some values. You have, just so you know, you have a keyhole right here. That key is your input. Jason, I'm about to kick you out of class. You're in the front row because I want you to know how close to the door you are. Okay? You're almost out. Sad is when you have that much talent, like you actually understand the math, but you can't stay in the class. Like one of the brightest kids in here in terms of the math, but you got to be able to actually stay here. And then function as what I expect a ninth grader should function like. Okay, negative 4 times B. Well, my input is 0. Notice that it's the only thing that's changing here is where my input goes. And I put parentheses there. What goes here?
1,
Here?
2,
And here.
3.
Now you have a bunch of math problems to do, just like we did in our warm-up. Negative 4 times 0 is?
0.
Plus 14 is?
14.
And that gives you a coordinate. Just so you know, the reason we do these tables is so you can graph it later. 0, 14. Okay, 1, negative 4 times 1 is negative 4, plus 4 is 10. So you get 1, 4. Or excuse me, 1, 10. Jason, will you get that, please? Negative 4 times 2 is? Yes. Negative 8 plus 4? 14, excuse me.
6.
6. Thank you, Jason. He's gonna get me like, you get me Domino's or something for lunch? I want pizza, man.
That was a change for me.
There you go. You did a good job. We were proud. All right. That's how you make your table. That's how you come up with your range. So my answer is actually this line right here. I didn't have to put all those points. I just did it because you guys enjoy math so much. See, Isaiah? There we go. All right. Hey, we're done with that. Right now, I want you guys to look at page 50 or 63 in your student journal. That is your assignment today. Page 63 of the student journal. Sure? All right. If you need help, make sure you call me over. I'll help you out.